Hello guys, and welcome to another video. So we'll be looking at this question relating to Newton's second law. Let's get right into it. The statement reads that a 5 kg trolley is at rest on a rough inclined surface which makes an angle of 30 degrees with the horizontal. A constant force is applied, causing the trolley to accelerate up the incline for 2 meters at 0.45 meters per second. Ignore the rotational effects of the wheels and air friction. This is our object on an incline, and this is our incline. As we can see it, we can see that we do not know the force at which this object is being pulled. And 3.1 says state Newton's second law of motion in words. If we state Newton's second law of motion in words, we'll say that when a net force acts on an object, the object will accelerate in the direction of the net force, where the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Okay, that's how you state Newton's second law, and you'll get 2 marks for that. So there's our Newton's law. When a resultant or net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the force and inversely proportional to the mass of the object. Okay, that's how we go about it. Let's go to the next question. The next question says, draw a labeled free body diagram showing all the forces acting on the trolley as it moves up the slope, and it's 4 marks. So this is how we'll draw a free body diagram. We will firstly start with our dot. There's our dot, and then we see that our object is on an incline, so we'll have a force like that. We'll label this F. There will also be the force of gravity or weight, so we'll have Fg. Then we'll have the force of friction. We'll say it's kinetic friction in this case because it's been indicated for us. And our normal force will be like that. Okay, let me just fix a bit. It should be something like that. It should be perpendicular to the surface. This will be our normal force. So this is how you draw your free body diagram, and you get 4 marks for this free body diagram. Now let's look at 3.3. It says, if the coefficient of kinetic friction along the incline is 0.18, calculate the frictional force on the trolley as it moves up the slope. Okay, for this one, guys, we will have to understand that if we have objects that are on an incline, then the normal force is not actually equal to Fg, but it's going to be equal to the perpendicular force. Okay, I'm just going to show it to the perpendicular gravitational force. So our perpendicular gravitational force will be like this. This is our gravitational force, that is the perpendicular force, and it's equal to mg cos theta, where theta is this angle that we find on the incline. So normal force in this case is equal to mg cos theta. Why is this? Because we are on an incline. Okay, so every time we're on an incline, the normal force will be equal to the perpendicular gravitational force. And for us to calculate this frictional force, we will remember, in fact, let's firstly find this normal force. If we find this normal force, we know that our m will be the mass of the object, which is 5, and then our g will be 9.8. Then our cos, the theta will be this 30 there on the incline. And what will be our answer? Let's see. So our normal force, guys, when I put all of this on the calculator, will be 42.44 newtons. Okay, That's our normal force, but we are not looking for the normal force, but what we are looking for is the frictional force, and we know that the frictional force is going to be equal to this. Okay guys, so the formula for friction will be, sorry about that, the formula for friction will be Fk is equal to the coefficient of kinetic friction multiplied by the normal force, and our kinetic friction is this, or rather the coefficient, it's 0.18, and then we multiply by the normal force, which is 42.44. And now what is going to be our answer? We'll put all of this on the calculator, and the answer we get here is 7.64 newtons. Right, that is the friction, and obviously this has to be in the opposite direction, downwards. Okay, that's going to be our direction there. And then we go to 3.3.2, and it says we must find the applied force F, and this is how we're going to do that. Okay, to answer 3.3.2 guys, we are gonna have to include another component force. Okay, so every time we are on an incline, every time our object is on an incline, it must have component forces, and those component forces are called what? The FG perpendicular, and the other one that we have is the FG parallel. Okay, the other one we'll have is FG parallel, and this FG parallel will be equal to mg sine theta. Okay, so we will be working with that as well, and then we focus on the horizontal forces guys only, and the horizontal forces in this case are this F that we want, the force of friction, and of course our FG parallel. The vertical forces would be the normal force and the FG perpendicular. These ones we are not going to look at. We are going to look at these ones that I'm going to circle in yellow, or let me use purple. We'll be focusing on the forces that I've circled in purple. So those are the ones that we'll work with. So let's find F. So for us to find F, we'll start by writing F net is equal to MA. F net means the sum of all these forces that are cycled in purple. So I will have F, and F is moving upwards, so it will be positive, but these ones are moving downwards in the opposite direction, so they will be both negative. FA minus FG parallel is equal to MA, and now I'm going to substitute here the F that I'm looking for. I don't know, minus this one is gonna be the value that I got here, which was 7.64, minus the FG perpendicular. My FG perpendicular is mg sine theta, so my S of the object is 5. If you forgot that, there it is, it's 5. And we also have our angle. Our angle theta is still this 30, so we will have 9.8 there for our G. Then we will have sine 30 degrees. All of this will be equal to 5 multiplied by the acceleration. Remember, the acceleration was provided to us. Please don't mind the previous part. This is the acceleration that we are given, 0.45. So that's what we are going to put here. Don't think I'm gonna have enough space, so I'm just gonna make the plan. So multiplied by 0.45. Then we'll put all of this on the calculator. This is what we are putting on the calculator. So we'll have F, then I don't know what the answer will be here. Let's calculate it. So when I put all of this on the calculator, guys, this part that is on the left, the answer I get is negative 32.14 is equal to, and then I'm gonna multiply this 5 with 0.45. Let's see what we are going to get. And when I say 5 times 0.45, I'm getting 2.25. And then this one, I'm going to transpose to the other side. So it's going to be positive when it goes to the other side. That means I will have f is equal to 2.25 plus 32.14. And then I'm going to add these two to get my force. And my force is 34.39 newtons. And that's how I solve that problem, guys. Let's move on to the next one. The last one says, will the frictional force between the trolley and the surface increase, decrease, or remain the same if the angle between the horizontal and the incline increases? Explain your answer. Okay, guys, when I explain this answer, I won't use words. I'm just going to explain, but you will take that explanation I gave and put it in words, okay? So here what we are being told is that our angle between the horizontal and the incline is going to increase. So when we answer this question, we will firstly look at the relationship between the angle and the normal force, okay? And the relationship, as you can see, it is inversely proportional. So that means if we increase our angle, then our normal force is going to decrease. So that's the first thing that we'll say, that increasing our angle will decrease the normal force, and therefore we will look at the relationship between the normal force and friction. And we know that if firstly, the normal force is directly proportional to friction. So if we decrease, or rather if the normal force now decreases, and that means the frictional force will also decrease. Thus our answer will have to be decrease. The frictional force will decrease due to the angle increasing, thereby having the normal force decrease. And because the normal force will decrease and it's directly proportional to friction, friction will therefore also decrease. That's how we answer that question. And that concludes this video, guys. I'll see you on the next one. Goodbye. Don't forget to like, share, and subscribe. Bye bye.